Hey guys, it's Casey and welcome back for another Unreal tutorial. So today what we're going to go over is that we are going to make a looting system. And I kind of want to stay away from making these very hardcore tutorials where it's just copy paste and move on. What I want to do is I want to tie these into bigger ideas. And what this ties into is data structures. And that is really just about how do we structure the data or information inside of our game. And this is like hugely important because say like a Diablo 2 style game or a Path of Exile style game or even MOBAs where you have several hundred if not thousands of items, maybe you have several hundred enemies too. Any game where you have like a lot of repetitive information, it matters a lot about how you structure that data, and it really comes down to before you really start working on adding all of it to the game. It's kind of like that the pre-work that you do, the setup that you do, because if you start to kind of get sloppy with it and you just kind of start throwing stuff in, you're going to end up maybe making like 50 items or 50 enemies, and you're like, wait a minute, this takes way too long to make one of them, and it just doesn't work right. Your code is getting weird, you're copy pasting a lot of stuff. So that's kind of what I want to do. Is this first video we're going to go over just how can we make a looting system, and then the next video is I'm going to try and tie it into a bigger idea of how important it is to structure data and how we should probably think about it. So for this one, we are just going to make a simple looting system. It's hard to say like the looting system because every game probably does it a bit differently, but we're just going to make an example of one, and I'll kind of go over how we can maybe change it a bit to fit different needs. So the first thing I want to do is we're just going to make an actor that kind of controls looting in a sense. It's going to control what comes out of looting. So this could be maybe like our, let's call it like our base chest. And the reason I'm just going to call this our base chest is that we are going to use this for a bunch of different things. Whenever something maybe dies, or maybe when something pops out of maybe a chest or something like that, this is kind of what we can use. So it kind of gets weird when I say when you kill something, but in theory, if we wanted to also use kind of the idea of a chest for when we kill something, in theory, when we kill an enemy, we could spawn this invisible actor right where we killed that enemy, and we can make loot pop out of them just as if it was a chest. So that's how we can kind of reuse the code there. So inside of this, what I want to do is I want to make an event, and we're going to call this event open. And on open, what we want to do is we want to go through our process of figuring out, first let's figure out kind of what do we want to drop. So the kind of the things that come to mind when I think about a looting game is we oftentimes have rarity and the kind of item that we want to drop. So to make things kind of easy, what we want to do is we kind of don't want to store, and this kind of comes back to how do we structure our information, how do we structure our data. In theory, if we ended up making another actor, and we'll just call this like our lootable item, we'll just call it item. Or we'll call it base item, I guess that would be a better way of naming it. Inside this base item, say we made a variable and we called it like our rarity. If we made this a string, which might be like our first kind of impulse, it's kind of sloppy because with this string, then we're going to be typing in like rare or something like that. But when we go to use this down the line, oftentimes what we're going to have to do with this rarity is we're going to have to do things like switch on string. And that gets kind of awkward because then we have to remember, well, crap, what were all of our rarities? And how were they spelled? And what were the capitalizations in case we use case sensitive and stuff like that? It doesn't really feel good. So oftentimes when you end up using these highly structured bits of words, what you want to use is you want to use enumerations. And in Blueprints, we can create enumerations by just right-clicking. And if we go under Blueprints, we have enumeration. So we'll add this, and we'll call this our rarity enum. And inside of this, if we open it up, we can basically add some strings inside of it. So inside of this, let's add our rarities, and we'll just make some like common. We'll make, let's say, rare, epic, and then let's do legendary. So now if we save this, what we can do is that if we do go inside of our base item, which we'll do this later, but if we just do that rarity again, instead of having it as a string, we can change it, and if we do the variable to what we just made, the rarity enum, if we save and compile that, you can see that I can now change its value to one of these. And that it makes it so much nicer to use later, because now we can do things like switch on this enum, or we can do equals equals on this enum, and you can see we can check, and it's so much cleaner than using just simple strings. It really structures the information really nicely for us. So inside of our base chest, what we want to do is we want to figure out the rarity that we are going to drop. So there's a bunch of different ways to kind of calculate what rarity, to kind of get the random chance and choose a rarity. I'm going to make a really simple one, and I'll kind of maybe talk about how there's some other ways. So let's make a function. And the reason why we're going to make a function here is that we probably want to reuse this. If we just did the code of choosing a rarity on this custom event, it might not feel good if we want to somehow calculate rarity in other ways or in other places. We're going to end up copy pasting code. So what we want to do is we want to make a function, and we're going to call it choose rarity. And then I'm just going to go back to the event graph, and I'm just going to drop it in there just so we don't forget. So on this choose rarity, what we want to do is we want to end up outputting out of this event a rarity. So let's work backwards a little bit. So we'll add an output, and we will call this, we'll change it to our rarity enum type, and we'll just call it rarity output. Did I spell that right? Rarity output. So with this, we know we eventually want to output a rarity. So simply what we can use is we can probably use a select if we wanted to here. This is one way of generating kind of a random, is that we can use a select, and that on this index, what a select is that we can add however many pins we want, and basically we can choose an input. The easiest input to use for this would be an integer, and we can do random int in range. And what random integer in range does is that we can say, let's say 0 to 9, so there's 10 options, 0, 1, 2, 3, all the way up to 9. So that means that every one of these will represent 10% chance. So what we can simply do, just a very easy way of setting this up, is that we can maybe make 4 of them be common. Let's do like 3 of them on rare, 2 of them on epic, and let's do 1 on legendary. So there would be a 40% chance for a common, 30% chance for a rare, 20% epic, 10% legendary. So before we really move on from this, so what this is going to end up doing is that when we open, what we're going to do is we're going to choose a rarity for our item, and then we're going to move on and figure out what item to drop. Before we move on though, the reason why this maybe isn't the best way of doing rarity is that, say we wanted this to be more dynamic. Say maybe some of the gear that a player has on is like 10% bonus to magic find or rarity find or whatever it is. It's kind of hard to modify this like dynamically through code. So another way of doing this is kind of what we could do is that if we wanted to, we could use like a method like this where at the start of choosing rarity, maybe we randomly generate an integer. Let's say let's use like 1 to 100. Now what we could do is that we could set up maybe branches if we wanted to. It doesn't feel great, but what we could do is we could maybe set up like a few branches here. And what we could do is say, if this number was less than or equal to, and then what did we say, 40% for common, so we could say 40 for common. If this is true, then we would output common. If not, well, let's actually move a step back. What we need to do before we do that is we need to promote this random integer to a variable, because we want to generate it once and then check against it multiple times. So what you would really need to do is you'd need to promote it to a variable, and we would call this our random int. And now what we could do is that after we set this random int, what we would do is we would check against it. So what would happen is that we would come through, we would set our random int, and that we would hit our first branch, and we would see if this randomly generated integer between 1 and 100 was less than or equal to 40. If it was, then we would output common. If it wasn't, then we could go through this, and that we could say, what was it, 30% for rare? So then we could add 30 to this, and we could say 70, and if it's less than or equal to 70, or actually I did greater than, no I did less than, then we could output rare, and so on and so forth, right? This would go all the way down till eventually we add epic and legendary inside of this. So what we could do if we wanted to is we could modify this, in that we could make an input here, in that we could change it to an integer, and we could say like our MF modifier, our magic find modifier. And with this, we could maybe add to this number here. So what we could do is, instead of doing just 40 there, what we could do is we could do 40 plus the incoming number, or actually what we want to do minus. I guess we would want to do minus here. In theory, if we had like 10% bonus magic find, we would want to make this 40 number smaller so that there's only a 30% chance of finding a common. So in theory, but this is kind of just semantics here, we could do 40 minus that number, and that this is a way that maybe we could dynamically modify this, and that maybe on top of this MF modifier, maybe this is also whether or not it's a boss, because maybe we want bosses to have a higher chance of dropping better loot and so on. So this method is a bit more complicated, but it does give you the options of kind of modifying it. But for our purposes, we're going to keep it super simple, and for the rest of this, we're just going to use this very simple method of just a very standard, it's always out of 100%, 40%, 30%, 20%, 10%. But if you wanted to know, there's a bunch of different ways of kind of generating this kind of randomness here, And this kind of method is a lot better for dynamic kind of runtime modification of the numbers. So after we generate a rarity, now we need to figure out maybe, let's say we wanted to break up the loot in our game, and that when an item goes to drop, we need to figure out exactly what it is. So we're going to figure out whether we're dropping gold, or whether or not we're dropping maybe a consumable like a potion, or we're dropping like armor or a weapon. So once again, if we wanted to, we could make another enum for this, because it's very clean to do so, and it doesn't really cost us anything at all. And what we could call this is we could call this our loot type enum. And now inside of this, we can just do those things that I just named. Let's just do 3 of them. We'll just do gold, we'll do consumable, and we'll just call it armor. Actually, let's just do another just to be clean, and we'll call it weapon. So now what we can do is we can kind of use the same method, and we can make another function. And actually, if we wanted to, we could probably just duplicate that previous function, and we'll call it choose item type. And now inside this duplicated function, let's just delete that stuff we did at the top. And what we're going to do is we're just going to right click this pin here, and what we want to do is we want to do change. Actually, oh sorry, we have to delete that. So first, let's change our output to be our new loot type enum. And what we're going to do is we're going to right click this pin, and we're going to do change pin, and we're going to change this to our rarity enum. No, loot type, sorry. I messed up. So let's do loot type enum. There we go. And let's rename this to our loot type output. Now if we hook that up, now you can see just as it was before. Now it's 40% gold, 30% consumable, 20% armor, 10% weapon. So let's just keep that for now. So now you can see that what's going to happen is that when we go to open this, we randomly generate a rarity, we randomly generate a loot type, and now with these 2 bits of information, we could now go through the items in our game and let's grab one. And of course, oftentimes with games, you need more than this. You'll probably need like an item range based on like maybe the level of the monster you killed. There could be a lot more to this, but we're going to keep it fairly simple here. And now what we need to do is we need to figure out how do we structure our items in our game. Because this is like a really big deal, right? If we have thousands of items, we need this to be like very simple, very straightforward, to add more, to modify them, to balance them. And personally, I think the best way to do this is to use data tables. So to make a data table, first what we need to do is we need to make a struct. And for simplistic purposes, I'm just going to make this for let's say armor. So we're going to call this our armor data struct. And inside of this, let's just make a few variables. First, we're going to make a name. I pretty much always recommend, if you're ever using data tables for things that you might need to call back to later, make a name variable, and I'll show you why we duplicate that. And that, well, let's just add some random things here. Like let's do our rarity. So it's going to be the rarity of our item. Then let's do another, and let's say we have I don't know, let's just add random ones. Let's add another, and we'll have it be maybe our armor. And actually, let's make another enum, and inside of our armor, let's get even deeper. So we'll make another enumeration here, and this one will be for the type of armor. The naming convention got a little off there, but that's okay. And here, let's do like the types of our armor. We have our head, we have our chest, we have our hands. Let's do belt, and let's do shoes. Or feet, I guess that's a bit more, and I guess waist would be a bit more proper there. And now what we can do is we can go into our data table, or our struct here, and now let's move that armor down one, and then let's make this variable, we'll make it our, what did we call that? Our armor type? Yeah, type of armor. So here we go. So now we have the name of our item, the rarity of it, the type of armor, and the actual armor value itself, like the actual like integer value itself. And now with the struct setup, what we can do is we can make a data table. And data tables are these wonderful things, and I've used them in a few other videos. And let's add a data table. When you make a data table, you have to pick a structure, and that's why we made a structure. Now we just need to find our armor data struct. We hit OK. Now let's call this our armor data table. And now the reason why this is so great is because this data table will work just like an Excel file. It'll work just like a SQL database if you know those. So what we can do is we can add a few of these rows, and we can just start adding some items. We can call it like the Helm of Doom or something like that. And that we duplicated this name value here, and now we can just copy paste that name down. The reason being is that when you pull a value from a data table, oftentimes later on you might need to call back to the name of this item. So it's good to duplicate names with data tables. And now what we can do is we can make this Helm of Doom, let's make it a legendary. It goes on the head and it has an armor value of 1,000, sure. And we can go on with this. We can make another helm and we can call this, I don't know, the Helm of Tor, and it's a common item. And let's copy paste the name, and we'll give it an armor value of 1. And you can see how we can go on and we can start making all of our things here. And the great things about these data tables is that they can import and export as CSV files, so that we can put them into Excel, do any balance changes we want very nicely with formulas in Excel. We can import and it'll update our data table. So it's really nice whenever you're dealing with bulk amounts of data that you probably need to change in the future, use data tables. So with this made, we can kind of pretend that we have a bunch of items in here. So now inside of our chest, where we're calculating what item we want to drop, we can now probably make another function. We can call it choose item. And now what we want to do is we can make an input for our rarity, or let's do our type. So it's going to be item type. And we'll make one more, and this one will be for our rarity that we calculated previously. And that we'll call that rarity. And now with these two bits of information, we can actually hook that up real quick. If we drag in our function, we can drag that in. We can get our rarity. Oops, I need to name that. Oh, no, it is named. It just needs to compile and give an error so that we can drag it in again. Now that fixed the name. Oftentimes with functions, when you rename variables, it doesn't update. You just have to re-drag them in. So there's our rarity. There is our loot type. And now inside of our choose item, what we could do is on our item type, we could do a switch here. And say with gold, what we could just do is we could calculate maybe how much gold to drop based on the rarity percentage and do a range, like a random integer in a range. We could choose how to drop consumables. But with our armor, because of how we have that set up, is that we can get our data table rows, get data table row names. Now with this, what we can do is we can get our armor data table, and we can do a for each loop on this. So what we're doing is we're getting out all the items inside of our data table, and we're going to loop through them, and we're going to loop through the names of them. And now with the names of them, what we can do with the name is we can get data table row. So it's kind of an awkward way of doing it, but first what we're doing is we're getting all the row names of our data, and then we're going through each one of them with a for each loop to actually get their data. So now what we can do is we can get break with our table, and now what we just did is we're going to loop through all of our items inside of our armor table, and we're going to see which ones match both the rarity of our item and the type of armor. So I guess I didn't do that part, but we can do that if we wanted to. We could make a new function real quick. I guess let's do that real quick just for the sake of doing it. Let's duplicate one of our previous ones just to make this simple, and we're going to call it choose armor type. And inside of this, we're going to do the same thing we did before. We're going to change this to be that new enum we made. I think we called it like type of armor. Yes, we did. And then we're going to call it armor type. And now with this, we need to change that pin to our type. Let's call it armor. Type of armor. There we go. And now you can see we're doing between our head, our chest, our hands, our waist. Once again, this might not be the best method of getting our randomization, but it is a method. And now if we go back inside of our choose item one, what we can do is we can, right before we do this looping, what we can do is we can figure out which type of armor we actually want to generate. And now what we have is we have 3 pieces of information. We had the type of item we need to drop, which we are choosing here, it's an armor. We have the rarity of the item we need to drop, and within the armor, we have the armor type. So now what we can do with our data table is we can check through all of our items and see which ones match our rarity and our type of armor. And if any of these items match both of these conditions, so they match both the rarity and the type of armor, what we can do is we can do a branch. Oops, this needs to be, oh, no, that is right. And now what we can do is if it matches both, what we can do is we can make a local variable, we'll make it a name variable, we'll make it an array, and we will call it compatible items. Compatible items. I might have spelled that wrong. And with this, for each item that matches our conditions, for each piece of armor that matches our rarity condition and our type of armor condition, we will take its name, so we can actually grab the name from here, and we will add it to this array. So in theory, what you might also need here is you might need like an item level and stuff like that. But in theory, we might have 100 items that match our condition, right? We might say we need a rare glove, maybe around level 50 and with some conditions on that. What might happen is we might have 50 items that meet that condition. If we want them all to have an even chance of dropping, we would loop through all of our items, find which ones match, and based on which ones match, we can then spit out at the end here, we can use this array, And a very nice way of getting a random element in here. Can we just do random? I don't think you do random. So what we need to do is we need to get one of the items, but how do we know how to get one of these random items? Well, very simply, we can get the last index out of this array, and what we can do is we can do the random integer again, random integer in range, and our minimum will be 0 because that's index 0. That'll be the first item, and the last item will be our last index. And with that, we can then just output out of our choose item, our function that we have here. We can output, and let's just do name, and we will just call it item name. And now at the end of all of this, what we will output is we will loop through our table, find all the items that are compatible, and at the end we will choose one of them randomly between index 0 and the last index of our array. We will get it out and we will spit it out. And now at the very end of all of this, we have the item that we need to spawn now. So that's pretty convenient, and it's pretty structured there, because now at any time we can go through and we can add more armor to our game, and nothing really changes with our code here. It's structured nicely. It's kind of future proof with balancing because we can export this to Excel, and it's pretty nice that if we do the work first to structure and think things through, it makes our lives in the future so much nicer. And if we wanted to, just for the sake of doing it, we could spawn an actor from class. Let's do spawn actor from class, and that we can then spawn our base item. And with this base item, let's just make a transform. And what we're actually going to do is I'm going to do a little cheat here. I'm going to add a new variable, and we're going to call this our spawn location. And we will grab a vector. Actually, let's do multiple, and let's do instance editable and show 3D widget. And what this is going to do for us is that if we go into the world, this is a little trick here, if we take our base chest where we just made that variable and drop it in the world, by making it instance editable and show 3D widget, we get our spawn location variable here, and we can add, let's say, 4 of them. And now we get these little balls here because we did the show 3D widget, and you can see here I can now drag these vectors out in the world, and we can drag them out and spread them out. And now what we can do is with these, we can then use them. So what we can do actually here is, instead of let's spawning 1 item, let's spawn 4 items. So what we can do is we can do a for loop, we can do 0 to 3, and once again, if we wanted to, we could randomize this too. This is the amount of items that we spawn when this opens. So we could randomize this information also based on certain conditions, and with each item we spawn, what we want to do, the spawn location, let's get out based on the 0 to 3 index, one of these 4, and we will pop the location there, and that's where our item will spawn. Let's make our item always spawn and ignore collision. And one other thing that we want to do is with our item, we want to take, let's delete this rarity out that we made before, and what we want to do is we want to make a variable called the item name. And with the item name, what we're going to do is we're just going to grab the name here, and with that, what we can do is we can make this instance editable, and this time we were going to make it expose on spawn. And what this does for us, if we go back to our item here, if we refresh this, we do our base item, you can see we get this item name node. And what we can just do is we can take the item name that we output from our choose item, and we'll plug it into our item name. Because the reason being is that while this item is on the ground, it's not going to do anything special, right? It just needs to know what its name is, and then possibly like what its mesh is, which you could also set up maybe inside these data tables, or right here inside these data tables, so that when we pop out the item, we just want to make sure it knows its own name, so that when the player picks it up, we know what to do with it, and maybe when it's on the ground, we can change its mesh, but we're not going to really deal with the mesh stuff here. That's simply just maybe inside this data table store which mesh it is, and that not only do we output the name, but we also output the mesh, or whatever we want to do with that. So now, what we can do is, if we wanted to, we could run this and we can punch out some items. But before we do that, let's actually go inside of our item, and just for some like simplicity purposes, let's add a cube to this, and let's make this cube kind of small. We'll pretend that's the mesh of our item. And now let's also add text to this, just so we can tell what we actually looted. We can just pop this text back. It's not going to be very pretty, but we can. And let's just make it above the cube. And now what we can do is, on begin play of this actor, what we can do is we can use its name, and we can get the data table row, and possibly this is where maybe we would want to pass maybe the item struct. But kind of the thing is that since this is an item, an armor data table, probably the other thing that we might want to pass here is the type of item, and maybe the type of armor or something like that too, right? Because we need to know that this item is an armor data table. So possibly the other way of doing that is underneath base item, maybe we do something like base armor or base, right? Like the item, when the item's on the ground, we need to differentiate between gold and the other things. So maybe it is better to make a child class, and those child classes grab the tables, or we need to pass through the information of how to figure out which data table we're using here and pass that in. So that's just a bit of random information there. Hope that wasn't confusing. But with this information, since we're just going to assume we know it's a piece of armor, what we want to do is with our text render, let's set the text, and we'll set the text to be the name of the item. And then the other thing we want to do is, and then the other thing we want to do is let's set the color of this, and we'll set the color to be equal to the rarity. So let's make a color. Oops, let's do like a, that's annoying. Let's just do select. And with the select, we will do our rarity. And with this, we can just do make. It's a little annoying, but let's make like the first one blue. Or actually, yeah, let's just make it blue. And we'll make the second, actually, let's make it like gray. How do you do gray? I can't remember how you do gray, but the alpha needs to be 1. Or 100, isn't it? I don't know. That'll probably be white, so it'll be hard to see on the cube, but whatever. Let's make the second one blue. And we'll make the third and the fourth just the other colors. So let's do green. And then we will do red. There we go. So in theory here, if I set this up correctly, when the item spawns, what we're going to do is we're going to use its information, both its name and its rarity, to change the text of this text that's above our cube. But since we only added 2 pieces of information here, let's actually change this helm of poor. Let's see. Since we only have a helm that's legendary and a helm that is common, we're actually going to manipulate our rarities here to kind of fit our needs. So what I'm actually going to do is I'm actually going to destroy the work we did here. We said it was common and legendary, and we're just going to make all of these equal to common and legendary, just so that it fits our needs here. And then inside of our choose armor type, we're just going to output head, because that's the items we made. But obviously you wouldn't want to do this. So now in theory, if we ran this, on begin play, we're going to loop 4 times. With each time that we're looping, we're choosing a rarity for the item. We're choosing the item type, and actually we need to manipulate that too, because we need that to be armor, because that's all we've made so far. And then after we choose the rarity and the item type, we go into choose item. And with these 2 pieces of information, we're going to go through our data table and figure out what items are compatible. Then once we add all the compatible items to our array, we're going to choose one of them randomly, spit them out. And with that name spit out, we're then going to spawn our base item. And with that name, we are going to, inside of our base item, use that name to then use our information to set our text and our color and stuff like that. So let's see if that worked. Let's see if we hit play. Did that work? No, it did not. So let's try and figure out what went wrong here. I did not expect that to go wrong. So we did our base chest. Let's see here. We looped through 4 times. Let's see. Did we not find an item? There we go. That's the issue. So our item type spit out gold. Why did that happen? It should have just spit out armor. Why'd that spit out gold? Let's see. If we play it again, what did it do? Why is it spitting out gold? It's spitting out common and gold. What did I do wrong here? So choose rarity. I'm wondering if we're having an issue with our enum here. And our item type is gold. But it's set to be forced to armor. I'm actually not sure what's going on with this enumeration here. This actually like throws a huge wrench in this presentation. Let's see. What happens if we change it to like consumable? Does it still spit out gold? That would be really awkward if it does. It spits out gold still. And that's always spitting out common. Oh, I'm an idiot. Sorry. We never ran this, we never set this event to run. My apologies. So let's set this to run on begin play, that event we made called open. I'm always don't remember to call your custom events or functions, people. Sorry about that. So now if we hit play, we still have issues apparently, but it ran this time. So we got common armor, and we spit out none for name. So let's see why that is. So we hit here, and obviously this should have been armor, because that's what the input was. The input was armor. So we got here, and we got to choose armor type. We should spit out head. And with that, if we go back into our choose item, so the rarity is going to either be common or legendary. And with that, we get the data table rows. And with each row, we are spitting that out. And we're checking to see if rarity. Let's see, did we hook up the pins correctly? Yep, that's going to rarity. that is going to armor type. If that's equal, we do that. So what we'll do actually here, how should we debug this? I guess we're going to do a little bit of debugging here because apparently I did something wrong. Let's actually print, let's print 3 things here. Functions are a little funky because sometimes when you hit run and we try and debug this, you can see it says variable is not in scope, and that makes some things with functions a little frustrating. So what we're going to do here is let's print some strings. The first string we are going to print is we are going to print the armor type to make sure we are spitting out head. And let's go back inside of our data table real quick, and let's see. Yeah, we do have our heads here. We have our legendary head and we have our common head. Okay, and the other thing we want to spit out is let's also print the string. Let's see, that's right, that's right. Let's print out to see if anything matches here. And we're just going to print out just hello to see if something matches. So when we hit play, we are getting hellos. Okay, so plenty of things are matching. And why is this not working? So then we are getting outs 0 to that. Let's see here. If we run it again, I didn't check the name output. And we're spitting out none. So why are we spitting out none? We're getting the hellos. We're adding the items here. So let's actually see. If we add a breakpoint here, will it let us debug that value? So we hit this value. Okay, there we go. Oh, I see, I see. Okay, so let's go into our data table real quick and let's delete these last 2 rows that we didn't add any information to. We'll start with that, and then we'll go on from there. So now when we hit play, we hit our breakpoint, and you can see it says it's Helm of Doom. We're getting out Helm of Doom, and it should spit out Helm of Doom over to our spawn item. So let's hit play, and boom, it should do Helm of Doom. Yes, it is, and we're doing our base item. I see. These locations, I just made a big boo-boo. These locations here, when we do these show 3D widgets, these are relative locations. And if you watched my video on relative vectors versus world space vectors, you probably looked at me and said, Casey, you're an idiot. Because the one thing we need to do here is that we need to add back in the actor location when we do this spawn. What we were doing is we were spawning things at the origin of the world, which the origin of the world was like somewhere up in the sky above us, I believe, or below us. No, it's below the ground there. So we need to add back in the actor location because it's a relative location to make it the world space location. And now everything should be running a-okay. And now, oops, let's remove our breakpoints. Sorry about that. Now when we hit play and we minimize, there's our 4 cubes, and you can see it spit out 2 Helm of Dooms and 2 Helm of Pores. And there you go. Our system is working with an extra few minutes of debugging there. So you can see how we could use this for a few different ways. We could also reuse this when we kill an enemy, let's say. One thing we could do to this is that we could add a movement part of this, and later on, if you guys want me to go more in depth, we can make it so that maybe we walk up to this right here and we add a chest and we press E, and the stuff doesn't immediately spawn on the ground. Maybe it pops out and it falls onto the ground. If you guys want me to do a follow-up video to show stuff like that, I can. But for the data part of it, this is kind of why we use structured data and why we think it through, why we use things like enums and data tables, is that it makes it very easy for us to scale this. And I think that's a very important thing. Whenever you're dealing with something that's going to have a lot of versions of it, say you have 100 spells in your game, or you have 100 enemies, or thousands of pieces of loot, whatever it happens to be, the system you're using needs to be able to scale. We can't just like I think some people get a little confused about how we deal with data, and I think I've seen some people, they make individual actors for their pieces of loot. Like, instead of doing this whole like information part, what they'll do is they'll take their base item and maybe they'll make a child of it, and they'll call this like the Helm of Doom. And that what you're going to end up doing is you're going to have 1,000 actors that you're duplicating, and that when you're going to spawn, you're going to have to choose from those thousands of actors, and it's not fun. That's sloppy. It's not like, it doesn't scale at all. So it's very good to think about how you structure your data, and I think that's what the next video I need to do. I need to think it through a bit more and how I want to frame it for you guys, but I really want to do just a video on structuring data and the different ways we can do it. And this was just a very obvious way, or an obvious, I guess, game mechanic that needs very structured data. So that's it for me. I've been rambling enough this video. If you have any questions, let me know. If you'd like me to like add to this a little bit and we can make this a bit more fancy, for those of you that like those kinds of tutorials, I guess I could spend some time to do it. So let me know, and I'll see you guys in the next video.